I got a request to do more probability on here, and I really like this problem. It lets us test our intuition and see how we think. The answer might surprise you. So you're testing 1,000 people to see if they have the flu. Now, to save money, you run actually only 100 batches with 10 samples inside of each. Now, the way the test works, if there's any flu virus in there, then absolutely it tests positive. And so the only way a batch would test negative is if none of those 10 people had it. Results are in, and 21% of the batches come back positive. How many of the 1,000 people do you think have the flu? Pause the video and think about intuition, but what I'm going to do is start with just a random guess. Like I see 21%. Let's guess that and see what it would do. If 21% of the population has the disease, let's think about what that means for the batches. If we take a batch of 10, what would be the probability it would test negative? Well, that would mean that all 10 of those people did not have the disease. And there's exactly a 79% chance for each person to be in that case. And since we need to make assumptions in this problem, but those are independent, and so we would do 0.79 to the 10th power, and we would find there's only a 9.4% chance that that batch tests negative. And now just subtraction, that must mean there's a 90.6% chance that that batch would test positive. That's huge, 90 or 91%, like we only noticed 21% of the batches testing positive. So our guess up here of 21% must be way too high. What's going on? Well, if 21% of people had the disease, that would actually mean 210 positive samples that we would be distributing in these batches. That's why we would get so many that tested positive. To solve this problem, we could do it again, maybe change this number to something smaller and see when we get closer to 21%. This is a great use of algebra because we can basically do everything we did before except with the number 21 by some unknown variable we're going to call x. So as before, the probability that someone doesn't have the disease would be 1 minus x, and we take that to the 10th power, and that will be the probability that a batch tests negative. And so really when we subtract that from 1, this is the quantity that we want to be equal to 21% because that's what we observed. I'll get out of the way and show you the algebra to solve this, but first I'm going to show you some visuals. This is that equation we were just looking at. And remember when we said if 21% of the population had the disease, we would expect 90 or 91% of the batches to test positive? That's what's going on with this point here. When you think about what we have, we only noticed like 20% of the batches positive. So we're actually looking down on the graph over here. I've kind of drawn this in so you can see that our answer is actually only around 2.3%. If you'd rather solve the algebra, pause the video and check this out. But in conclusion, we're going to estimate that about 23 of the 1,000 people actually have the flu. It might seem unintuitive that only 2.3% of people can actually lead to a 21% of positive batches. But that's because these 23 people are probably getting spread into lots of different batches, and that's what we're seeing. If you have another way to solve this problem, I'd love to hear it, and I'd love to hear your thoughts in the comments. Thanks for watching.